All right, this is the second video for Notes 88. We're going to do question number 4 and then question number 5. So question number 4, we're looking for the sides and angles of the following right triangles. So we're going to be dealing with our lovely little mnemonic device for trigonometry. Make sure I spell it right or else it's going to get really confusing. So remember, this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in question part A here, I've given you a 38-degree angle. I would like to know the other angle. I'd like to know the two sides. So let's start with finding angle Z. So I know the three angles of a triangle are supposed to add up to be 180 degrees. So I'm going to take the 90-degree angle I know, plus the 38-degree angle I know, plus angle Z, and that is supposed to equal 180. Let's see if I can do the math. 90 plus 38 would be 128, plus Z is equal to 180. I'm going to subtract 128 from both sides, and Z is going to equal... my brain is fried. 52 question mark. So having said that, because I don't want to steer you guys wrong, this would be awful if I can't do math right now. So let's see, 90 plus 38 is absolutely 128. Okay, that I could do. And then 180 minus 128. Hey, I can do math. Go me. All right. So angle Z is 52 degrees. All right, so we know that one. All right, all jokes aside, I thought I had it right, but I just wanted to double check. Okay, I am going to now, I'm going to use the 38-degree angle as my reference angle. Okay, so from here, I want to label the triangle. So 12 is the hypotenuse, y is the adjacent side, and x is the opposite. I need to find both x and y. Let me kind of narrow this in, and I'm going to move, can I move this? I cannot. There it goes. Okay, I'll move that over there. This way we can see that SOHCAHTOA reference. Okay, so I want to find both x and y. I can't find both at the same time, so let's go ahead and just find x first. So I'm going to use the 38-degree angle. X is opposite, and 12, which is the hypotenuse, is what I know. So opposite and hypotenuse references SOH, so that's going to be my SO, which means that is the sine of 38 degrees equals the opposite side over the hypotenuse. Okay, and again, that reference would be SOH, so that's so. How do we solve this one? I'm going to put this over 1. I'm going to cross multiply. X is equal to 12 times the sine of 38. And I keep popping this calculator back up and forth because, well, sometimes I need it, sometimes I don't. All right, so let's do 12 times the sine of 38. Quick reminder, I want to double check mode very quickly. So I'm going to hit the mode button here. I want to make sure that degree is highlighted, which it is. So clear out of that. That way this is correct. So 12 times the sine of 38. I'm going to round it off to 2 decimal places, and we're going to go for x is, there's my x. X is equal to 7.39 because the 7 after the 8 would round it up. Okay, so make the calculator disappear. Get my triangle back here. There's all the triangle. So now I know what x is equal to. Love that. But I got to figure out what y is equal to as well. So what do I know? I know my angle still. I know y is the adjacent side. I'm going to go back to using the hypotenuse here. Like to use that. This is what I know. So let's see. Adjacent and hypotenuse. Where's my little mnemonic? There's the AH. So we're going to be using cosine this time. So the cosine of 38 is equal to the adjacent side, y over the hypotenuse of 12. This is, again, the mnemonic CAH. We're going to put that over 1, cross multiply here. Y is equal to 12 cosine of 38. There, no, that's not my calculator. I thought the calculator was still over there. All right, calculator time. So 12 cosine of 38 degrees. It's still going to be in the right mode, but you can always double check. And then check it. Y is equal to, round it off to a couple decimal places, 9.46, because it would round up. All right, so there are the bits, parts, and pieces. I'm going to circle up, there's my y value. Circle up y. So I've got your part A is done. We figured out what angle z is here. We figured out what side of x is, and we figured out the side of y there. All right, so that's part A. Sliding on over, part B is the same exact kind of problem. So let's see what we got here. I am going to find x first, this angle, then I will talk about finding y and z. So for x, I'm going to take 29 plus my 90-degree angle plus x has to equal 180. Let's see, 29 and 90 is going to make 119 plus x equals 180. Subtracting 119 from both sides, 61. I'm going to double check that because I'm going to. Okay. So if you're sitting here staring at the video going, that's not right, you didn't add, yeah, I'm going to double check my own work. So 29 plus 90 is 119. 180 minus 119 is in fact 61. All right. So we've got that angle figured out. That is done. Love that. Let's go ahead and use, again, it doesn't matter in these problems if you use either of the acute angles. You just want to pick one of them and stick with it. I'm going to pick the one that was given to me. This way there's no question that that is a 29-degree angle. I'm not questioning that the other one's a 61 degree, but let's go ahead and use the 29-degree angle here. So I'm going to go ahead and say that this is the angle I'm looking at. That's what I'm going to use. So label the triangle. There's my hypotenuse. That is the right angle, points at it. That one's good. If I go from the 29-degree opposite, that's the z, and the adjacent side is going to be y. So of course I need to find y and z. You can't find both of them at the same time. So let's say we want to find y first. So that's the adjacent side. 8 is the hypotenuse. Adjacent and hypotenuse use C8H, which is going to be the cosine of 29 degrees equals, what I say there, adjacent, which is y, that's a y, over 8. So cross multiply here. We're going to get y is equal to 8 cosine of 29. Let's go ahead and pop that in a calculator. It always shrinks when I do that. So 8 cosine of 29, 6.996, which would mean that y is equal to basically 7. It would technically be 7.00. I would accept 7 as an answer because all of those 9s would round up. Okay. So I know this keeps bouncing around as I'm popping that calculator in and out, but there is our cosine value for y. We figured out what y is. Now, of course, I need to find what z is. So let's see what we got for z. Z is the opposite side. We know the hypotenuse. So the little mnemonic is going to be SOH, S-O-H. So the sine of 29 equals the opposite side, z, over the hypotenuse of 8. We can put that over 1 to cross multiply. So let's see, 1 times z is z, and it's going to be 8 times the sine of 29. All right, it's going to get weird because I'm going to pop the calculator up here. So that shrunk down. Get back here and shrink. There we go. Let's see, 8 times the sine of 29, 3.88 when rounded. Because it would be 3.878. That 8 will turn the 7 into another 8 there. All right, lose the calculator, get all the pieces up there. Whoops. And there is z. So for this particular problem, you found x. We found that first, then we found y, and then we found z. The order that you find these two, y and z, it won't matter. Just find both of them. And then make sure you also know how to find that third angle of a triangle. All right, so that's question number 4, part A and part B. That's dealing with SOHCAHTOA and using your trigonometry. Now, question number 5, you might look at it and say, oh, it's the same thing, but I want you to be super careful. Question number 5 is a throwback to your special right triangles. This is a 30, 60, 90 right triangle, so we're going to label it as such, right? The side opposite 30 is x. The hypotenuse is 2x. The side opposite the 60, whoops, I wrote that the wrong thing, is x root 3. So I know what x is. X is 3. So everywhere I have an x, I'm going to replace it with an x. Now, if you don't like the fact that this says x and that says x, no worries. Let's take those x's out, and you could say it is a, 2a, and a root 3. It won't matter, but if it does get a little confusing because I labeled this as x and that as x, then don't use those, okay? Don't use x. So everywhere, in this case, now that I think about it, I have an a here, that's 3. Well, that's going to be 2 times 3. Well, wait a minute, 2 times 3, whoops, that's just 6. And where I have the a here, I can replace it with 3. So that's going to be 3 root 3. And these are going to be exact answers. So this is exactly 3 root 3. That's exactly 6. If you tried to use trigonometry, sine, cosine, and tangent, you would never get this exact answer of 3 root 3. You get some kind of decimal equivalent. So be careful with the 30, 60, 90s that you're using the exact answers. All right, last one on this page is a 45, 45, 90. And again, we're looking at exact answers here. So 45 and 45, these two sides are going to be identical. Now the problem already has an x in it, so don't use x again if that's confusing. Let's call it, I don't know, t root 2. If you don't like that, use something else. Okay, but what this tells me is these two legs are identical. So whatever x is, y is going to be the same thing, right? T and t. But then this side is supposed to be whatever t is times root 2. Now, this is not a typo. This is exactly what this is. So I'm going to start with what I know. I know that t times root 2 is supposed to equal 4. Well, let's figure out what t is. Divide both sides by root 2. So that gets me t is equal to 4 over root 2. I don't like the fact that there is a radical in the denominator. So I'm going to rationalize it and multiply through by a root 2. So this becomes 4 root 2 over root 2 squared, which at some point you might recognize, oh, wait a minute, root 2 squared is just 2 because the root and the power undo each other. So that square root and that power of 2 are inverses. It just leaves behind 2. But wait, you're not done. Because now that you've done the work of rationalizing here to create the 2, this fraction can be reduced. And so I'm going to do that. 4 root 2 divided by 2 is going to be 2 root 2. So after all this hard work, all these steps to rationalize, reduce, all the things, I now know that t is 2 root 2. So these two sides are both 2 root 2, 2 root 2. So the answer here, answer here. All right, that is some examples using SOHCAHTOA up at the top, some examples of using your right triangle trig at the bottom, and those are actually not right triangle trig, but that's the special right triangles. That's the word I was looking for. All right, so that's going to be the end of this video for notes. I think this was 88. As always, if you have any questions or concerns, please let me know.